In this video, I'm going to look at some of the way fractions work in Julia. Julia seems to have this amazing way of representing fractions without actually evaluating them. So we can represent 2/3 as the complete value 2/3 rather than worrying about 0.6667 or 0.666667. So I'm going to see how Julia treats fractions and see if there's something interesting here I can share with you. My name's Chris. I'm a programmer traditionally. I've been working... My name's Chris. I'm an engineer / programmer / data analyst who's been working with various programming languages over the last 15 years. I've just taken a dive into Julia recently to see what sort of features this up-and-coming language has to offer. I'm also working towards building a special project in Julia. I'm hoping it'll be some sort of dashboard. So stay tuned, hit subscribe if you're interested in seeing that, seeing how that evolves as we go. So I've got here some information, there's another screen I've got here, some information about the different ways to work with fractions in Julia. So let's start with that 2/3 example. So usually if we just do 2 divided by 3, it turns out it's 0.6. Now it hasn't done any rounding here, but you can see on this left-hand side where the workspace is that there is rounding that's been applied. I'm actually going to just see if I can pop this up. Just give me 1 second. Oh, that's handy. So what I'm talking about with fractions is this rational that I've ended up searching for. I didn't realize the documentation was down there. But okay, so back to our Julia prompt. So what I've done is put 2/3 in and it's given us 0.666. However, over here in the workspace, you can see it's truncated to 0.667. This might not seem like much for typical applications, say a dashboard where you're showing different meters or levels. However, it can be incredibly important if you're using the programming language to do maths. So in Julia's case, Julia is quite maths heavy. Or quite maths focused, I should say. So it is important. These small differences can be important. So Julia offers another syntax that says, let's take a look at that. We now have a fraction represented as our answer. So let's try this again. X equals 2/3, Y equals 2/3. As you can see, there we go. Now, I'll speak in a different video about comparisons and control flow, but let's see what happens if we try to equate X and Y. So what it's saying there, what I've done here is asking Julia if X equals Y, to which Julia has said no. One of the tricks I learned from back in my C days was to ask the computer what the type of the variable is. So I wonder if that will work in Julia, type of X and type of Y. So what we have here is that X has been represented as a floating point number with 64 bits of precision. I'm using the 64-bit version of Julia. Now, this means that floating point numbers are kind of out of the scope of this video, but it's a way of representing decimals on a computer where typically computers deal with binary integers, so ones and zeros, integers that are represented with ones and zeros. Floating point is another way to handle precise calculations for long decimal numbers. And we know that decimals can go on for a long time. Decimal numbers can be represented not by fractions, but by infinite decimal places, such as pi. So Julia has ways of representing these floating point numbers with as much precision as is required. So that is this rational number. So this is a rational of integer types. I wonder if we can have a rational of floating point types. Let's try that out. Let's try Z equals 2.1 divided by 3.2. What does that happen? Error. Okay, so we're not allowed to use floating point numbers in our rational. It has to be integers. What else? Let's see what else we can do with these. So we can pull out the numerator of Y should give us 2, and the tab work? Yes, denominator of y gives us 3. So this means that we can get Julia to do our fractions homework. So are there any are there any primary school kids out there looking to work on fractions? Julia can help you out. For example, Julia, your teacher might ask you, what is 37/55 plus 2/3? Julia should work this out for us and give it to us as another fraction. So 221 over 165. So if we do the same thing as floating points, we can do divided by 55 plus 213 gives us that, and 2 to 1 divided by 165 gives us that. So the decimals do look right as well. And it looks like Julia can help out with primary school fractions homework. So if you are interested in fractions homework, check out the different maths operations that can apply to Julia. We can, let's try scalar multiplication. So 2 times, let's try that, 37 on 55. That gives us 74 on 55, exactly what we'd expect. We can do equality. So for example, does 2/3 equal 6/9, which is true, it does. We can do inequality. So is 2/3 less than 3/4? Yes, it is. Excellent. We can do multiplication, is quite easy, of course. 3, 4, 1, 2. Excellent. 6/12. And then we can change. So remember our y here is 2/3. We can change y into the decimal point number simply by calling the float conversion, the float type conversion. And in fact, it should be that this equality works out. Excellent. So Julia can equate those two floating point numbers when they're floating point numbers. If you'd like me to do a video on what floating point numbers are, leave a comment down below. Though I'm sure it's the sort of thing that's not really related to Julia because all programming languages use floating point numbers. We can, some interesting information that the Julia documentation provides is infinite rational values. So what happens if we divide by 0? Yeah, that's interesting. So we can leave 1 divided by 0 as a rational. Let's make z equal 1 divided by 0. And we can ask for the denominator of z. Interesting. What happens if we convert z to a floating point number? Yeah, okay. That's interesting. What if we do mathematics with z? I see. So remember we did the scalar conversion. So we do 2 times y. 2 times y. We get 4/3. But if we do 2 times z, we still get the same as z. So does that mean that 2 times z equals z? Yes, it does. Oh, that's really interesting. So this kind of works out what you'd expect mathematically. That 2 times infinity is still infinity. It's a concept rather than a fixed number. So I'm glad Julia can recognize these things. This would make it quite a powerful tool for university, which is probably why it's so up and coming for data analysis. So that said, I don't imagine you'd have any trouble completing this sort of behavior in another programming language such as Python. So I haven't used Python to do such maths in the past, though I'm sure it can handle it quite well. Okay. We can't, however, construct a 0 divided by 0. What happens if we do 0 divided by 0? But we can't do, we can't do a rational not a number, but we can construct not a number by dividing 0 by 0, but we can't construct a rational not a number. So we can't turn that into a rational. Oh, okay, that's interesting. What happens if we have 2, 0? So if we have 0, okay, interesting. Let's see what else we can do. Okay, so that seems to be it for fractions in Julia. Julia seems more than capable of handling fractions naturally, including all the sort of arithmetic you'd expect to be able to do on them. This includes strange cases such as infinity or not a number, and Julia seems to handle those with ease. So if you'd like to see me cover more on the sort of maths operations that Julia can do, leave a comment below and let me know. But overall, what I'm working towards at the moment is building some sort of dashboard in Julia. And hopefully that I can show you that one soon. Stay tuned, and I'll be releasing these videos regularly about how I learned Julia. So hopefully it helps you learn Julia as well. And I'll see you in the next one.